So consider this equation that is given as x, and in the power of x we are having this expression that is 3 over 4 times log x base 2 squared plus log x base 2 minus 5 over 4. This is equal to square root of 2. Now these are the following options, right? So let's see how can we solve this one. So first of all, I'll jot down the equation as it is, right? Now in the next step, I'll be taking log x base 2 on both the side of the equation. So consider this equation as it is, and here log x base 2 I'll take for both the sides, right? For this one and as well as for this part as well. Now here we can use the property of log, but before that I'll simplify this and then we'll make substitutions over here, right? So using the property of log, we can clearly observe that this power can be written here as it is, right? I'll write within parenthesis, and this will be log x and here base 2, and this square root of 2. So in the power of 2 we are having 1 over 2, so this will be half of log 2 base 2, right? Log of argument 2 and base 2. So this is essentially 1 again. Now considering this, now this one is already 1, so I'll eliminate this part. Now we can observe clearly that we have log x base 2 everywhere, right? So what I'll do, I'll make an assumption, let u is equal to this log x base 2, and I'll substitute this u over wherever the appearance of log x is there, right? So this will be b over here, this will be b, or simply this can be written as b square again, and this is b. So on arranging this equation in proper form, it's a cubic equation because of the highest factor as b cube. So this can be written as 3 times b cube plus 4b square minus 5 times b minus 2, that is equal to 0. Now on factorizing this, if you observe, on substitution of 1, this is satisfied when you substitute b equals 1. So b minus 1 is one of the factor, and the other factor, other quadratic factor would be 3b square then plus 6b plus 7b. No, this would be 7b, right? So this would be 7b plus 2. 7b can be written as 6b plus b. 3 2 is 6. Now without skipping this step, so here 6b can be written as, sorry, 7b can be written as 6b plus b. Now solving this quadratic, this can be, so from this is a quadratic expression. So if I resolve this part, if I solve this part, you can observe 3b is common here, so this will be b plus 2. So you can observe 3b is common, so here we will have b plus 2, right? And here 1 is common, so again the other factor is b plus 2. Now on resolving this, we'll get here that is 3b plus 2, sorry, 3b plus 1, and then this will be times b plus 2, that is equal to 0. So these are the three different values of b that we get over here. So b belongs to this set, that is negative 2, then we are having negative 1 over 3, and then 1. So essentially here, instead of b we can write log base 2 of x, right? So for this one we can write, instead of b we can write log x base 2, right? So here I have considered u actually, so I have considered b actually, right, instead of u. So I've taken here b over here instead of u. All right, now here this b can be replaced by log x base 2, log base 2 of argument x. Now on resolving this, on converting this into exponential form, so x can be written as, this will be 2 to the power negative 2, so this minus 2 will be in the power of this, and this one will be in the power of this 2 again, so this 2 to the power negative 1 over 3, and this would be here 2 to the power 1, that is 2. So these are the three real values, right? So this particular equation on solving, we are getting 3 real solutions, for which you can observe that one of this is irrational, right? So here if you observe, at least one real solution, yes, one real solution is there, but we need to check for other option also. So technically this option A is correct, but we need to get precise answer. Exactly 3 real solutions. If you observe here, 1 2 3, we are having exactly 3 real solution. Now out of A and B, so this B is even more accurate. Exactly one irrational, yes, this is also partially correct, because one of that is irrational, but other real roots are also there, right? And then complex roots, no, we do not get any, we did not get any complex roots. By the way, every real number can be treated as complex numbers, so this also can be considered correct. But out of all of this, the most appropriate option is option B. So for this problem statement, option B is the correct answer. So answer is option B. So that's the solution.